Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And today we have another lesson for you in Visual Basic, and this one's on validation of program inputs. So we're going to be looking at checking data which users have entered onto a screen form, and also checking selections and options they may have chosen by using like drop-down lists or radio buttons on a form. So we did look at validation in previous programs, especially the rectangle, perimeter, and area program, the one before this lesson. Although it's not absolutely 100% essential, we recommend that you have done the rectangle, perimeter, and area before you do this lesson, but let's get into it. Okay, so in this lesson, we're going to look at how to check the inputs which they've either put into the screen in text boxes as data entry or selections they've made with radio buttons and things like that. All right, so we've already learned a lot about validation in that rectangle calculator lesson. So in that lesson, we were looking at putting in some validation so that if they leave the drop-down list boxes blank and go and click that calculator button down there, it's going to come up with an error that they need to choose the units for length. So they need to go in here and click onto that. And likewise, if they do put the units in, but there's a mismatch, so if they're doing meters and centimeters, that's not going to work out. We need them in the same units for our particular program and application, and so the length and width must be the same. All right, if you're in the USA doing this lesson, just think about inches, feet, and yards and miles, and you could change the program to do those instead of the metric units we've got here in Australia. So a common way to develop any application program is first just forget about doing any validation, just get the basic program working okay. So what we do is we just get our rectangle calculator, get it going there so that people can enter in data, they put in the correct units that match, everything's good, they want to do the area, they click calculate and it gives an area answer. All right, so we test the program out for all these different combinations. Also, maybe they put decimal values in for length and width and make sure it's all working, but, and there's always a but, what we need to do then is we need to think about applying some what we call the Homer-Simpson tests. All right, so apply Homer-Simpson test. We even got a button there for it on the form. What type of crazy things might someone like Homer Simpson do to the program? All right, so we need to thoroughly test for all kinds of crazy possibilities. So when we've got Homer on the program here, he might want to type in the length and the width as being 5 and 2. T-double-O, that's 2, that's the number 2, Homer. All right, now if you do that and click calculate, the whole program's going to crash at the moment because it's got no validation in it. And there's going to be an exception crash because Visual Basic can't take that 5 and turn it into like 1010 binary sort of internal memory input that it can process. So the program just totally crashes out. Don't, Homer, you've done it again. All right, so Homer Simpson, he's not the sharpest knife in the drawer. We're not necessarily picking on him. We love the Simpsons, and like Homer is dead set really funny. But yeah, he's going to put in all sorts of foolish and ridiculous things. He's the ideal person to test our program to make sure that it is bulletproof. So always think about doing these Homer Simpson tests once you've got the basic program working. And by doing those, you'll know where it's failing, and that'll give you an idea of the validation which now needs to be put into the program. So input validation, the first thing is existence checking. So Homer might be trigger happy and he just decides to jump straight down to the calculator button. Oh, I wonder what this button does, without entering any data at all, and that's going to cause a program crash. So the form is empty and the program crashes. Oh, okay, well that's not too good. We need to fix that up with some input validation. Okay, so usually the first validation check we do is that existence checking or presence checking. So on our form, we want to check that all the boxes have been filled in properly by the user before we go ahead and try and do any calculations or any program processing. So existence checking is the first thing we're talking about. Okay, so the program will crash with blank and empty inputs. And why does it do that? Here's the program we had previously for the case statement lesson, and that would crash if you clicked the go button without entering anything into the text box. And the reason it happens is it crashes with the exception error because the contents of this is just kind of spaces or blanks. And in ASCII characters, it's not a number. So Visual Basic recognizes, hey, there's no number there. I can't go and do my 1010 kind of binary stuff on it, and I can't process it. So that's it. I'm quitting. You don't give me a number, I ain't doing it. Bit like a kid who doesn't like Brussels sprouts, I guess, for dinner. Brussels sprouts are on the table. I see Brussels sprouts. I ain't eating them. Brussels sprouts are actually really good and really nice. An acquired taste in later age. All right, so we need to do validation to trap bad user input and prevent these types of crashes. Now, when we did the adding two numbers lesson, I remember back on that we had this same problem, and we used some try, catch, end try processing to fix that. So hopefully you've been doing the course in order as you should, and you have some memory of that. But we'll be going back through it anyway. So some errors might not be the user's fault. We've been picking on Homer a lot, but you know, Homer might be frustrated that with those drop-down boxes we've supplied, ours is a metric calculator, and there are no, when he tries out these drop-down boxes over on the right-hand side here, there's no inches, feet, or yards, the thing that Homer and Americans use. So we've been really nasty to American people with this application. So he might think, okay, I'm just going to type in 28 feet and 6 feet and calculate it in feet because I'm an American, I do it in feet. All right, and then the program crashes, and that's kind of really nasty to Homer. We should actually enhance our program so that we've got more in the drop-down list. We could easily add more items in there, inches, feet, yards, and miles, and make it an international program, all right? So that's something maybe you should go back and do on the rectangle, perimeter, and area program. Right, the three main validation techniques. Input validation is the idea of it is to prevent bad data that's going to crash the program or cause bad results to come out. There's presence checking, making sure things aren't empty, making sure they've clicked on tick boxes, radio buttons, selected something from a drop-down list and not left it all blank. Okay, there's also type checking and range checking. Like we saw those programs crash if Homer put his feet on there, because then that input box doesn't have a number in it, so it's the wrong type. It's not number type, and Visual Basic can't do it. There's also range checking, like our numbers for this area and perimeter need to be greater than 0 is the range of them. They need to be positive numbers. We're not working with negative numbers in that sort of measurement. All right, so good validation will stop Homer's silly or confused input values from getting anywhere near the program processing, so it'll cut it off and stop all those crashes and bad things from happening. So think of validation once you've put it into your program, it's kind of like a security guard or bouncer looking after the program and making sure that there aren't troublemakers that cause problems there, because we'll tell them they're making trouble straight away before trouble can get out of control. Now, it cannot guarantee that the data is accurate. So validation can only check something's reasonable, okay? That there is a number in the length box. Now, if Homer accidentally fat fingers 1200 when he really meant to press in 12.00, validation can't fix that. It can't make sure it's 100% accurate. It can only make sure it's reasonable and it's the right data type for the program. So just remember that, especially on exam questions, a lot of students write, oh, by doing validation, we can make sure the user's input is fully accurate. Well, it won't make sure it's accurate. It'll only make sure that it's reasonable. So be aware of that on exams, especially if you're doing software development or computing in Victoria, Melbourne, here, Australia. So adding input to our program, how do we do it? There's two main ways to do it. Method one is the try, end, try. Catch processing, which we did in the add two numbers program, if you can remember back to that. And there's method two, which is doing the dedicated DoValidation subroutine and using a really long ElseIf statement, which is what we did in the rectangle program you've done previously. Now, method one is really quick to set up and test, so it's highly efficient. If something's fast and easy to do, that's called efficiency in data processing and software development. Method two is more effective because we can actually pinpoint exactly what's wrong on the form and put up message boxes to give the user specific messages about what's wrong and how they need to fix it. So as we'll see in this lesson, method 2 is the superior method. It can identify and alert users to all of the input errors that are a problem on the form. So method 1, the try, end try, that cannot do range checks or cross checks. It can't check that if they've put centimeters in for lengths, that the width is also centimeters, okay? It can only check for if there's number type or if there's blank, but it can't do cross checks and other things we need to do as well. So it's not really the best method. A dedicated do validation subroutine, it seems like a lot more work, but look, after you've done this lesson, we will have given you an easy to follow framework to do it for when you need to do it in all of your programs. All right, so let's just go back and review the try, catch the exception, end try processing. All right, so the idea was that when you have calculations about to happen and some CDBL convert to double or cast to double conversions there, we want to try do this processing. So this is telling Visual Basic, hey, try out doing this stuff. But you know, if anything exceptional happens or bad happens, just stop it right there, okay? And put up a message box to the user. So it's going to catch the exception before the program can crash. A bit like that bouncer kind of getting rid of Bart and Homer before they made any trouble, and putting a stop to it right there and then. So look, it is good processing and it's quite easy to code in, but it's not the best. Now we've got a step-by-step Word document for this lesson, so we'll just go across to that and show you. So in there, it goes in detail, step by step, what to do. So this is available in the download. So if you go to the video description, click on the link for the downloads, it'll take you to the lesson on our web page, and then you'll be able to get this information. But yeah, it's got the code there, so you can copy and paste it in. That'll save you a lot of time because we know you guys are really busy, and try that out, okay? And what'll happen is when you try it out and test it out, if these are blank, the processing works fine, tells them they need to enter some values for that stuff. And if they put in non-numeric stuff, like try typing in the units as well as the numbers, it'll catch that before it can crash. It does its try catch and puts a stop to that, puts out a nice error message to the user there, and that's all working fine. Okay, so the trouble is that, like we were talking about, if they do meters and kilometers, try catch can't pick that up. So it's not really the best method that we could be using for our validation. So it's much better to use this method 2, this if, else, and then an EndIf at the end of it. So I write a separate do validation subroutine that's going to do all sorts of checking, and it's kind of works off a checklist. Before we write the routine, we need a checklist, a validation checklist. Now, what is a validation checklist? Well, think of like when pilots, if you've ever been at the airport and been looking at the planes closely, the pilots sit in there before the passengers get on and while they're getting on, and they're going through a checklist, right? They're checking that all of the cabin gauges are working and responding, that the engines are actually running properly, that the wing flaps are moving okay up and down. So if you're sitting in the plane, often you see all the things on the wing moving around like that when you get the wing seats, the cheap seats that Passy flies with. And like when you start a modern car too, it's got this whole computer program in it and an engine management system. It's actually doing validation. It's checking that your brakes are okay. It's checking that the airbags are okay, that the anti-swerve steering system's working, all these things. And if something's wrong, it puts up a kind of a light indicator on the dash, meaning, uh-oh, got to take this to a mechanic to get fixed. All right, so the same pre-flight, pre-driving check sort of thing, that's what we need to do for our program. Now for our program, this is our checklist for that rectangle, area and perimeter program. So we need to check that the length and width boxes, that they're not blank, check they're numeric, check that the values in them, if they've passed those first two checks, that they're not blank and they've got numbers, make sure they're not negative numbers or they're not 0, because you can't have a 0 length or width. So they've got to be greater than 0. Check that they've put those units in, whether they've put, centimeters for both of them or kilometers for both of them, and that they're both the same units, that they haven't put like millimeters for one of them and kilometers for the other one. or if you've made yours an American program, check that one isn't in inches and the other one isn't in yards, and check that the radio button that they've picked whether they want to do area or perimeter. Okay, so you need to check all these things. They'll just have the form there, they click the calculator button, that'll then trigger this checklist happening, and our program will go through the checklist, and it won't try and do any calculations or do anything until every item on this checklist is perfect and we're ready to go. All right, so just for one of the checks, just the coding for it. So in our step-by-step guide, we've got all of the coding there for you, which you can download and copy and paste to save time. But look, just for that second check where we're checking if the length and width are both numeric, how that works in the coding is in that DoValidation subroutine. This is the actual little section of coding that does that. So it's checking the text input length.text. So that's the text box on the form where they type in their length. So is that numeric is the check we're doing here, which is a built-in Visual Basic function. If that comes up false, that it's not numeric data in there, well then we're going to put up this message box to them and tell them, hey, you've got to input some whole numbers or decimals for length and width. You've got an error here. And it also checks what's in the width text box with this second lot of code here. And again, if that's false, if it's not numeric, it's going to put out a message for them. If there are numbers in both of these boxes, well then it's fine, and it won't actually go in and look at any of this code. It'll just go, oh yep, it's numeric, skip to the next one. Oh yeah, it's numeric, and then it'll skip to the next one in the program, okay? So if they have got some stuff which isn't numeric because maybe they're frustrated American users that we've been so nasty and horrible to, and they decide, well, we're just going to put those inches onto the measurements anyway because we need inches on ours, not any of that metric stuff. Unfortunately, it's going to tell them they're wrong, that they have to enter whole numbers or decimals, just number values in here, no kind of units, no kind of letters of the alphabet or anything like that. So for the full set of information about this ElseIf do validation, this is pages 8 to 11 in the step-by-step guide. So this is going to be a little long, so if you need to pause the video and take a little break before you look at this, we suggest doing that. But anyway, all right, so we're going to jump across and look at that now. All right, so method 2, the dedicated submodule. So in the calculate button process, if you double click on your calculate button on the form, you need to put this code in, and it's going to call a separate module called do input validation. We'll talk about the modules and how it works a little bit later, but we did talk about modularisation a lot in the rectangle perimeter program, so go back and review that if you've got no idea what modularisation is. But it's basically going to be working on our checklist. Every time they try and click the button, it's just going to be working on the checklist and waiting until everything's okay, until all the checks have passed, and then when that's true, then it'll do these other subroutines. All right, so what is the separate validation subroutine? Well, if we have a look at our checklist, okay, here, we need an existence check. So to check the text boxes are not blank, the length and the width, that's called existence check. I think Americans call it presence check. It's the presence check. But anyway, existence or presence, make sure they're not blank. Then checking they're both numeric, that's a type check. That's what we call it in validation. That's checking that they're number type, the correct type of data. And checking that they're both greater than 0, that's actually a range check. So validation has 3 main checks: existence, type, and range. They're your 3 main types of validation checks, and you need to know that kind of stuff for exams and stuff like that in the course. All right, so here's the do input validation module, and let's have a look at that. So all we're going to do is we're just going to write some code to do each of these checks, and we're going to do it for both length and width each time we do it. All right, so this first lot of code is checking whether that text box that's got the length, is it null or empty? So we're checking for, this is the existence checks or the presence check. We're checking that there's something in it. And if it's empty, this code will be triggered, that if statement will be true, and it's going to put up a message box and tell them to enter values for the length and width. Then, okay, maybe the length was okay, so then it'll just ignore doing that and it'll come down and say, let's do the next check. So it goes to the next else if. Here it checks whether the input width text box, where they put the width in, is that null or empty? And if it is, it's going to put out a message value to them. And it won't go and do any of these. It's just going to stop there, with the message value. They'll have to fix it up. They'll have to press calculate again, and then it'll come right back up the top and do the checking from the top. So the idea is if the users are really messing it up, hopefully each time they fix stuff and press calculate, it'll get a little bit further down the checklist. All right, the next thing in the checklist is checking, this was the example one we looked at, whether the data is numeric. If they have got numbers in there, this will be fine. It'll go, okay, that's good, tick it off, goes to the next one. If the numbers are 0 or they're negative, well, then it's going to bomb out and give them a message. It'll say you've got to put a value greater than 0. So it'll stop here and put the message box up. They'll have to fix it up. They'll have to then click the calculate button again. Then it'll run all the way down these checks, and this time it'll be okay. Here it's checking to make sure on the combo box, the drop-down list, that they haven't left that blank for the units which have to be entered. And if they have left it blank, it's just going to stop everything, put out a message on the screen to them and wait for them to fix it, and click the calculate button again. And it's not kind of smart enough to know it's already done all the other checks. It just starts from the top again and goes through the whole checklist. Now, eventually, everything will be correct. They will have even clicked an option, either the perimeter radio button or the opt area has been clicked. So they've picked either perimeter or area. Everything's good. So when it comes down the checklist, okay, it's going to go all of these. Yep, that's okay, that's okay, that's okay. And as long as things are okay, it keeps going, that's okay, that's okay, that's okay. And it gets to this final else. All right. And if it gets right down to here, everything is ticked off on our checklist, and it can set Boolean input data okay is true. All right. Now, when you code this, right, you do not just type in all this code, sit there for like 10 or 15 minutes, just madly typing it all in and go, yep, great, my validation's finished, I'll test it. It's best to do it a little bit at a time. So the 80-20 rule, yes, this is a pain. This last 20% of putting validation into your program is probably going to take 80% of the time and effort writing that code and testing it to make sure it works 100%. But look, just put the null or empty checks in first. Just code that bit and then just test that out and see whether it's bringing up messages when things are empty. And then once you got that all working, then put in the is numeric check. So add your checks into the code one by one by one until you've built up that giant DoValidation module. All right, don't try and code the whole thing at once. That's just absolutely crazy. Now, another thing is object focus. Now, you might want to pause the video at this stage, go and play around with some validation checks for either the area rectangle program or another program you've got perhaps that you want to do some validation on. So just pause the video and go off and do that, and then come back and we'll be looking at object focus. All right, object focus. This is just something we add in as an extra kind of step in each of our validation checklists. When something's wrong, it's a bit like if the pilot was going through his little written checklist in there. When something's wrong, he might put a big highlighter pen through it to highlight, well, got to check out that one. Well, this is what you do here. You put the focus onto the actual item on the form, which is incorrect. All right, now we need to go and have a look at pages 12 to 14 of the Word doc, because in the rectangle area and perimeter program, we kind of went through this focus stuff a bit quick. And from some questions we've had from our students, we realized perhaps that was a bit quick and we need to go back through it. So let's have a look at this whole idea of the focus. All right, so if an error has occurred in the width text box, for example, then we put text input width dot focus double brackets, okay? Now that's gonna put the width into that text box to focus it onto that text box. All right, so here we go. Someone's put in width 2.10 centimeters. They wanted to type centimeters on there and not just leave it as a number. So the error will come up. That's not numeric. It fails the type check, and we get that error message. Now, after they click the OK, because we've put text input width focus onto that, what's going to happen is that after they click OK, the cursor will be flashing in that very box. It might be a bit hard to see here, so I got it a lot bigger. And it's even going to be focused and flashing where the problem is. So the 2.10 is fine, loves that. That's a number type like it should be. But hey, it's saying, what's this CM stuff on the end? That's not numbers. So it pretty much tells you what you need to do. You need to just delete off that CM. And then next time you click calculate, it's all going to be good. All right, so that's how you focus into a text box if something's wrong there. So if you've done the error message and then afterwards straight away you get the focus going on there in the code. All right, maybe we should just show you the code for that, which we haven't put into that step-by-step doc. Oh, here we are here. So if the text box for the width was wrong, we're going to put that out onto the screen for them, and then we do a text input width dot focus straight underneath. So that means when they click OK on the message box, it's finished this line of code, and then it goes to the focus, and it's a focus there which shows you exactly what's wrong, with the cursor actually blinking and flashing at you, focused in that text box telling you what's wrong. Now you can also focus radio buttons, so focus can be applied to radio buttons. So if they haven't picked a radio button, we could do opt perimeter.focus brackets. But the trouble is that that's a bit of a problem, because it's going to then click the perimeter button as selected. All right, so we don't want to kind of select it for them. The whole problem was they've left it blank. Maybe they want to pick area. So they might be all confused if suddenly they see after the message box, hey, you didn't pick anything. No, what's going on? Perimeter's picked there, it's clicked and it's showing. So we don't usually put focus onto radio buttons, okay? So don't do that. Now focus and drop down list, that's okay, we can put it in there. So if they've left something blank here, so they haven't put in the units for the width, so you can see here, enter width. They've got the width, but they haven't used the drop down list to get the units. So we have the message box come up, choose the units for width. When they click OK on that, we're putting the focus onto that combo box. So the focus will be on there, the cursor will be there blinking in that combo box telling them, hey, you need to put something in here. So they hopefully will click that down arrow and fix that up. All right, so that's kind of a bit more detail on focusing. It's great to use for text boxes. Don't use it for radio buttons. And it's great to use for a combo box if they haven't picked anything off the pick and click list in the combo box. So that was something we wanted to clear up with this lesson, which didn't come across clearly in the previous rectangle perimeter lesson. All right, so that's all done. And now the ready to go flag after validation. So I've been talking about how it goes through all those checks, goes through the checklist, which has been coded with all this if, else if coding, which looks horrible and looks like a lot of work. But look, once you've done it for 2 or 3 programs, you're just going, oh yeah, I'll just go back to my old program. I've got some stuff. I'll grab it, I'll copy and paste it in and fix it up. All right, so it becomes a copy and paste and just changing exercise. You won't be sort of writing those giant slabs of code every single program. But anyway, at the end of that validation subroutine, if all the checks are okay, we talked about the importance of that else statement, which sets the ready to go indicator. It tells us Boolean input data okay. Finally, our data is okay and it's true and we're ready to go. So once that happens in the DoValidation module, that goes back up to the main module. So remember in modularisation, we're talking about like, if you had a recipe for making a curry, you might have kind of a sub-process like making the curry paste by grinding up all the spices and then putting all these other things into a blender and blending it until it's really smooth. So you're doing validation checks, is everything really smooth and runny, kind of like a paste liquid? And once it happens, that's finished. Well, then you go back to the recipe and go, oh, what's the next main process I have to do? And that might be cutting up the vegetables. So once it's finished validation and it gets this all clear, yep, validation's all done, it automatically goes back up to the main BTN calculate main module, just like checking the recipe, what do I do next? So the next thing it does is the calculations. All right, so it'll come back up to this main button calculate module, and it will see that input validation's done, everything's all clear, it says the data is okay now, and so it goes off and does calculation, does output, which is separate subroutines in the program. All right, and the main thing is it protects these subroutines and it stops program crashes, because it's not going to go off and try and do any calculations with blanks there or non-numeric things that'll cause casting errors and make a program crash, because we've got this protection turned on. At the start, we assume, okay, this data might not be okay. Let's just set it to false, that we're not ready to go yet, and we're not ready to take off in the plane because we haven't done our pre-flight checklist. We're going to do all that checking until everything is A-okay, and then we know we're clear for takeoff, all right? And once that is okay, then we can go off and do these other things. All right, so all of the validation checks in the checklist must have come up okay for that to get set to true and for the rest of the program to execute. All right, so we've done it with modularization. We've got the calculate button just has this code in it, which is driving the whole process. And think of this like when you see spy movies, that first up, Boolean input data okay is false. So in a spy movie, like they're going to go into this room and have this discussion or something, but at the beginning they assume, hey, the room might be bugged, nobody talk. And they go all around the room looking for little bugs and listening devices and destroying them, right? So that's kind of like them doing their input validation. They sweep the room and they check for listening devices and destroy them. All right, so they're just assuming right up front, hey, it might be unsafe in here. Let's not do anything until we've done all the checking we need to do, found all of those bugs and listening devices and dealt with them. And then once that's okay, the room is clean. They say, yep, the room is clean. And then they sit down and have their discussion or whatever, you know, in the movie. So there's no listening devices. People can now speak freely. Once we've done a validation, we know our program's all clean. We're ready to do the calculations and do the output. So this is a really useful, just little set of standard code that you're going to use in every program you make. You're going to modularize it. You're going to set, okay, things aren't all right. Let's set it to false. Let's do all of the checks that we need to do for the data, which is on the form and the radio buttons and things for this particular program. We'll put that in a whole separate big long if-else-if module called do input validation subroutine. And then we'll have other subroutines to finish off the program doing the I, P, and O, the processing and the output. All right, and we're not going to let those processes go. They're not going to happen until we know everything is clean and ready to go. All right, so that's kind of it. It protects the rest of the program from trying to go ahead with bad data and crashing or getting you know, the wrong answers or things wrong with it. All right, now the other thing we didn't really talk about in the rectangle and perimeter program is testing. So if you need to take a break, you might take one now, because yeah, this is ending up quite a long video, but we really need to cover all these things. These are all fundamental basic things that you need to know for doing application development, software development, making programs. All right, so testing. Once we've got all that coding done, we need to actually test it and make sure it's all working. So we return back to our validation checklist and have a look at that and work out, what do we need to test? Okay, well, on this first one, for blanks, we're going to have to test the length text box and the width text box. When both of those are blank, or maybe one's blank and the other one isn't. So there's going to be 2 tests needed there, maybe even 3 tests, because you might want to test both blank, length blank, width blank. But let's just say there's 2 tests needed. To check that they're both numeric, well, you're going to have to check the length and the width, so that's another 2 tests. You go through your checklist thinking about the tests you need to do, and that's like a total of 11 tests. So it ends up being quite a lot of testing as well. So, you know, you probably go gnashing and grinding your teeth now, hating validation because there is so much testing involved. But look, that's the way it rolls. So you need to test, hey, what if both are blank? Is my message coming up telling them that they need to put stuff in? What if they've put in the length, but they've left the width blank? Do we get an error message for that? You know, what if they've got the length blank and they've done the width? Okay, give them the error message. So we've got to make sure all that checking's working. So they've put in their length and width, but they haven't chosen any units. So we need that message to come up. We need to set up a test where they've done length and width and one of the units, but haven't done the other one. Click the calculator button, see what happens. Okay, that's all working beautifully. It's asking them to put in the width units. So this is why the if-else is great, because it can pinpoint exactly what's wrong. And then remember, when they click OK, you'll have that focus, so the cursor will actually be flashing in that box there, telling them that's a drop-down list thing they need to do next. All right, so choose the length ones. Okay, so we got all that. Then check the this one for if they've done meters in one but centimeters in the other. So if these 2 drop-down list items aren't identical, well, then we don't have the same units. We give them a message. The units for length and width must be the same. So that check off our checklist is all working. So on and so on and so on. We do all of the tests we need to do. Okay, and that's all good. So we've done all of those validation checks. And later on, we'll see about doing testing tables. So I have a separate lesson we'll do for you on testing, because it's even more work than that. It's more work than just getting the print screens. You actually have to do it all in a testing table as well. All right, but after that, okay, we did a lot of changes to our program, modularizing it and putting in that validation subroutine. So I've actually got to go back and test all the good test cases again. So forget about Homer, kick him off from using the program, and someone smart and intelligent like you is doing it now, and you're going to enter everything correctly. But we need to make sure all of this stuff still works. That, okay, if they do everything correctly and the checklist is all fine, let's actually go ahead and get the right answers. So you've actually got to do all those tests as well. And that's quite a few tests, and they're on pages 21 and 20 of the step-by-step document. So there's a lot of testing. So, you know, the 80-20 rule, 20% of your time will just be, hey, I've got my program working, it's all great, everything's perfect. And then the other 80% of your time will be adding validation for all of the silly input which people could do on your form, and also testing that everything, including the validation, the wrong stuff, and all the good stuff, that it all works. That's going to take up the 80% of the time, even though it's kind of like 20% of the eventual product that goes out. So let's just go here. So yeah, validation in other programs, we've only looked at that kind of area program and perimeter program. But look, names, if people are typing their name into a program, that should be text and hyphens. You shouldn't have numbers or special characters in there. And then there's dates. If people are doing dates, well, for Australia, they need to be in day, day, month, month, year, 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 and you need to let them know that, because USA dates are the other way around. They're month, day, year. If you've got the number of students doing a course, well, that should be numeric. If you have an image field where they're storing an image, make sure that's not a text file. It needs to be like JPEG or PNG. If you had a drop-down list or kind of sort of radio buttons where they click something, you know, they have to click one of these Australian states. If they haven't clicked that, well, then don't go ahead. That fails validation. We're not ready to go. It's failed our pre-flight checklist. Credit card numbers, they could accidentally type the letter O instead of a 0. So somehow we have to figure out what's the difference between O and zeros, and how can we detect that and do validation. And these other ones, like a customer ID, they're supposed to do 6 letters, or if something's only 3 letters for the customer, fill it with spaces. And then on the end, have 3 numerical digits. Or maybe a product code should be 4 numerical digits followed by 8 text characters. There's also a thing called check digits. So when you've got really long numbers, like a really long bank account number or the ISBN code for a book, they put a special digit on the end of it, like an extra digit called a check digit. That's not part of the identity number, but what it is they do this mathematics on the rest of the numbers, and if the check digit comes up wrong, it means somewhere you've typoed the rest of the numbers, okay? And yeah, so they've got that sort of check digit stuff as well. And when you put in credit cards, you know, the system always knows whether it's a MasterCard or a Visa card because of kind of some different digits that are in the number that are used for checking. All right, so there's several specific validation techniques that we have not covered in this lesson. And one of them is string validation using ASCII codes. So we saw ASCII codes way back, I think, when we did data types at the start of the course. And every single character on your keyboard has this ASCII value. So to check that a person's name hasn't got numbers or special characters in it, there's only got letters or maybe some hyphens, you can actually take each letter one by one in the name, which is called string processing, and you can check whether it's like one of these ASCII numbers for a big capital letter or one of these ASCII numbers for a little letter, and do that. And you can do the same sort of things for customer ID and product codes and other things. But look, this has been a monster lesson. This will be a whole separate lesson coming up later on about how you can, yeah, check names, product codes, ID codes and all that sort of stuff. You need to do validation on them as well when people are entering that data onto a form. So anyway, the lesson resources for this lesson are free of charge, okay? So if you click the link in the video description, you can get both the PDF, which is sort of the slides for this lesson, and the full step-by-step Word document guide. So that guide, our students, some students just like to do things quickly, and they'll just grab this guide and quickly scroll and scan through it. Or if you need to go back and check stuff later, like, oh, how do you do that focus stuff? you know, they'll go back to where focus was in here and just see, oh yeah, you put it in the code here like this. All right, so for some students, they just love this guide and they use that and they don't even watch the video. But other students that want things explained to them, they're really happy to watch the video. So it's best to get all of these resources, especially if you're a teacher or an instructor that's going to run this class in your course with your students. So we've kind of made this one a free one, and this gives teachers and instructors a chance. They can trial this lesson. So you get the video, you get all the resources, try it out with your class if they're learning input validation, see if it helps them. And if it works out well, then you might want to look at getting a whole bunch of our other lessons as well. If it doesn't work out well for you, well then don't get any of our lessons, I guess. So we're pretty confident though that most of our other satisfied customers, especially for the Microsoft Access database course, which has been around a bit longer, yeah, people are buying that, they're very happy with it. Some students are just using the quick guide slides to find out how to do things and do lessons. Other ones are watching the videos. So this will save you, if you're a teacher instructor, a mammoth amount of preparation time. I know, because I got a day job in a high school, how much time it is trying to get coursework together for your classes. And like, yeah, if you've got something really quick and easy and cheap as chips, or even free like this one to use with your classes, I mean, that will just make your life so much easier. I know what it's like being a teacher, and I want to help you guys. I want to help everyone around the world to teach programming better, to learn programming better, and do all these things. So we've got the full programming course on our website. So the link for that is in the video description. You can go to the programming course just by clicking on the programming button here. If you want to do the database course, Microsoft Access, you can click on that one. And there's a direct link for the programming course right there. So that's that information as well. So subscribe to our channel. We're putting out videos, new videos every week. Make sure you like this video if you found it helpful. Drop us an email about your experiences trialing this with your class if you're a teacher or instructor. And you know, we're putting out videos probably on the weekend. One a week is what we're managing at the moment. So subscribe to our channel, click that little bell to get notified when a new video is up there, and enjoy programming with Visual Basic.